Hello everyone. Today we want to talk about a new topic, which is resistivity of the rock. It's an important topic, which is related to the saturation topic as well. So let's start by introducing some of the concepts of basically resistivity. I think you already know what is resistivity. It's the resistance of the rock to the electrical current. It's called formation resistivity, and they can basically transmit electrical current. These rocks can transmit electrical current by means of their water content. So the water have some ions, anions and cations that can transfer the electrical current from one side of the rock to the other side of the rock. The rock itself, if you have a dry rock, if it's entirely dry, then it has infinite resistivity, which means it's not conductive to the electricity. So, but if it has water, which usually in the formation water we have salt dissolved inside the water, then the electrical current can transfer. So the higher the concentration of the salt, you will have greater conductivity, which means that you have lower resistivity. Now, we have multiple components in the rock. We have the rock grains, or matrix as we call it. We have some pores, which inside the pores you have water, oil, and gas. Now, water, usually what we have in the formation, as I just mentioned, water have some salt in it. It's basically salty water. So if you have a salty water, then it's conductive. Oil and gas, they are non-conductive as well. So rock grains or matrix, oil and gas, they are non-conductive materials, or they have very high infinite resistivity. Water, on the other hand, it has a low resistivity to the electrical current, and this basically difference in resistivity would help us to determine this water saturation inside our reservoir. So we kind of mentioned these. Please make sure you read these slides. As many factors affect resistivity, which we will talk about them in terms of, for example, porosity. Porosity is one of the important parameters that would change the resistivity. So we'll go over all those parameters in next slides. We mentioned basically that this is the change in amount of the water that we have inside the pores would change your resistivity. So based on that, we define a parameter which is called formation resistivity factor. And this formation resistivity factor is a parameter that would help us to determine the water saturation in our reservoir. So before defining the equation for formation resistivity factor, I want to first introduce a couple of parameters, couple of basic concepts of resistivity. So the first one is basically the brine resistivity. So assume that you have a bucket like what you see in this picture, and in this bucket you have brine or salty water, right? So you pass some electrical current through this block of water, and there is a electrical voltage that is being applied. So the current passes through this, and then you can measure the resistivity. So resistivity is usually shown with capital R. So capital R that you see here is resistivity. We have another parameter here. Let me put W, which represents the brine. Lowercase letter r, W, is called resistance. They are different slightly. So the resistance and resistivity, they are related to each other by means of the cross-sectional area of your bucket basically here, which you can see it's shown here. This is the cross-sectional area perpendicular to the electrical current divided by the length of your bucket. Okay, so this is how resistance and resistivity are related to each other. And from physics, you already know that resistance is equal to electrical voltage divided by electrical current, right? So if you substitute this into this equation, then you get this equation for water resistivity. So Rw is equal to electrical voltage divided by electrical current that is passing, multiplied by cross-sectional area of your sample divided by the length of your sample. So this is the resistivity equation for brine. Now, how do we find these brine resistivities? It depends on how much salt it's dissolved inside the water, and also it is also a function of the temperature. So Schlumberger have published a chart that you can find the resistivity of the solution. I forgot to mention in previous slide the unit of the resistance is in ohm. That's how we show it, and that's how we write it, ohm. The unit of resistivity, however, is ohm meter. So you can look at here that if your cross-sectional area is meter squared, your length is meters, your resistance is in ohm. So basically the multiplication of all these parameters is ohm meter. So you can see this is actually ohm meter here. And then on the x-axis, what you see is the temperature. This is in Fahrenheit. This is in degrees Celsius. And what you need to do is to read the temperature, whatever temperature your sample is at. And then on the right side of the y-axis, these values are the amount of salt that is dissolved inside your water with a unit of pound per million. So part per million. So you can see these numbers, different salinity amounts. The higher the value of parts per million is, basically the higher the salinity of your water. So whatever salinity your water has, you can go all the way to that. For example, let's say you have a brine that has a salinity of 20,000 ppm. So what you need to do at 75 degree Fahrenheit, for example, you go up until you hit 20,000, and then you go to the left side, you read the resistivity of your brine. In this case is 0.3. So 0.3 ohm meter at 75 degree Fahrenheit and 20,000 ppm brine solution, right? So that's how you use this chart to find your water resistivity, or RW, which we talked about it here. Another concept is, now just assume that instead of that bucket of water, you have a sample of rock, and this sample of rock have some porosity, and within those pores you have 100% water, 100% brine, the same brine that we just talked about in the previous slide. So you have its rock 100% saturated. So this is 100% saturated with water, and you pass the same electrical voltage through this rock. Then you have another electrical current measured. So if you use that, we can calculate the resistivity of this rock 100% saturated with water, And the way we show it is with capital RO. This is called resistivity of a rock 100% saturated with brine. Okay, now the ratio of this R to the brine resistivity is this, right? This ratio is very important, as we call this ratio formation resistivity factor. So if you have a piece of rock sample, you saturate it 100% with the brine, and you know what is the resistivity of the brine, then you calculate the resistivity of your sample 100% saturated with water divided by the resistivity of the brine. It gives you a number which is called formation resistivity factor, and we show it with FR. Okay, so you can see the definition of FR here in this slide. This is FR, RO over RW, very important parameter, and you can see that it depends on the resistivity of the rock, 100% saturated with brine, and the resistivity of the brine itself. Now, so there are multiple factors that affect this formation resistivity factor, which I will talk about it in the next video.